Alright, so what kind of images that are formed by convex lens? Alright, so if all the rays they are coming from infinity, okay, so very far, if the rays are coming, in that case they form a point image. Okay, they meet at one point which is called as a focal point. Alright, okay. If you have an object that is at a distance of 2f or ahead of a center of curvature, in that case that object will form an image between f and 2f. Okay, so that will form an image between f and 2f, and the size of the image would be smaller as compared to the size of actual object. Now when you keep the image, when you bring the image at 2f, okay, when you keep the object at 2f, the image is formed at 2f, okay, and the size of the object is same as the size of the image. Okay, so the image size is same as that of a object size. Okay, when you bring the object between 2f and f, okay, that means close to the focal length, in that case the size of the object, it starts increasing. Okay, so it enlarges, the size enlarges, and it goes away from the center of curvature. Okay, so it goes ahead of center of curvature. Now if you bring it very close or at the focus, the lines they go parallel, and hence no images formed, or very blur images there. Okay, or very enlarged images there. Okay, so we can say that there is no image that has been formed when it is at focus. And when you bring the object between the focus and the lens, okay, in that case the lines they diverge. Okay, and if you follow the reverse path of it, in that case you'll find a virtual image. Okay, there will be an erect, a virtual, and an enlarged image that will be formed. All right, hence it is also called as a magnifying glass. So a convex lens also acts as a magnifying glass, so it is also called as a magnifying glass. All right, now we'll just look the same thing with a different perspective. All right, so for example, on your optical bench, you place the lens. All right, so you place the lens on the optical bench and you place your object needle. Okay, and from this side you will be observing it. All right, so in that case, when you will first see that the image is erect. When it is very close to it, it is erect. As soon as you start moving the needle away, in that case it will start enlarging. Okay, so what you are actually seeing is a virtual image of it from this side. Now once it comes at focus, the image is highly enlarged and you won't be able to, it won't appear like an image. Okay, it will be highly enlarged. Now once you move it further away from the focal length, in that case now you'll see that the image is inverted. Okay, now from here you are observing, from here you'll observe that the image is getting inverted. Okay, and it is still, okay, it is inverted now. Now it will, when you take it away from it, it will again continue to remain inverted. All right, so in our experiments what we'll be doing is we'll be keeping the object first at 2f, and then we'll increase this distance. Okay, so this distance, okay, from the object till the lens is called as u. Okay, and from the lens to the image that is formed, okay, that is called as v. So we, in our experiments, we will be increasing this length, so u. So initially we'll keep it at 2f, that is this distance, and after that we'll move it. Okay, so we'll move the lens, that means we are increasing this distance. Okay, so if we'll increase this distance, what will happen? Okay, the image will come over here. So first it will be at 2f, and after that it will be less than 2f. All right, so let's see that.